Hello students, in this video we will see the activities of the chapter 1. These activities are so much important because from this activity lots of question is asked in the examination. So we see the first chemical reaction, which is the exothermic reaction. For this process we require a calcium oxide, water, one litmus paper, beaker and test tube. Now let's see the activity. For that, take 1 gram of quicklime, means the calcium oxide, means CaO in a beaker. Add 10 ml of water into the beaker. Touch this beaker during the reaction. Then after, put a red litmus paper into the beaker after the reaction. Here you can see when the calcium oxide is react with the water, the calcium hydroxide is formed. Due to this reaction, the beaker is become hot and a colorless solution is produced after a reaction. And the red litmus paper is turned into the blue red litmus paper. Now what we are learned from this, or you can say what is the outcome by this process? The beaker is hot during the reaction because the heat is produced when the quicklime react with the water. The colorless solution produced at the end of the reaction is the basic in nature, as the red litmus paper is turned into the blue color. Now let's see the next activity. In that we study about the precipitation reaction. The formation of barium sulfate precipitation. Let's start the activity. First of all, take the 100 ml of water in a beaker. Dissolve a small quantity of a sodium sulfate, means Na2SO4. Take 100 ml beaker in which add some water. Dissolve a small quantity of barium chloride, means a BaCl2. Here the sodium sulfate formula Na2SO4, whereas the barium chloride formula, that is BaCl2. Now let's see the observation. There is a change in the color of a solution in both the beaker. After we do the final activity, add the solution of both the beaker and mix it well. Now let's see the final observation. During the addition of the barium chloride, you can see there is a changes occur in the color due to sodium sulfate react with the barium chloride and which is precipitate. Here you can see the barium chloride's precipitation is occur. The conclusion, or you can say the learning outcome, that the sodium sulfate react with the barium chloride to give a white color precipitation. Now let's see the third activity, that is a burning of magnesium ribbon. Let's see the activity. For that, take a 3 cm long magnesium ribbon. Use a sandpaper to rub and clean the ribbon. Hold the ribbon using a pair of tongs. Burn the ribbon using a split lamp or a burner. Now let's see the observation. A dazzling white flame is produced when the magnesium ribbon is burned into the oxide, burned into the air, or you can say the oxygen. A white powder is formed and which is collected into the watch glass. Now let's see what is the outcome. Here the two reactant, that is a magnesium which is in solid state and the oxygen that is its gaseous state. Both they are combined and form the magnesium oxide which is solid in nature. And the one product is made. So this process is known as a combination reaction. Magnesium powder is formed due to the reaction between the magnesium and oxygen which is present into the air. Now let's see the fourth number activity, that is a testing of hydrogen gas by the chemical reaction. Let's start the activity. Take a few zinc granules in the conical flask. Then after, close this conical flask. After that, add 5 ml dilute hydrochloric acid, means the dilute HCl, into the flask. During this reaction, be careful because we are using the hydrochloric acid which is acid. We can see the observation that there is a change is occur into the zinc granules. Now let's do the final activity. Bring a burning matchstick to the near a conical flask mouth. You can observe that the stick is burned with the pop-up sound. The beaker is warm if we are touch it. What is the learning outcome? That a chemical reaction is involved in both the breaking and formation of the bond. A change in the state of the substance is occur. A change in the color of the substance is occur. And during this process, the release of energies occur. Here, the formation of the precipitation is occur. Now let's see the another activity in which we can see the heating of calcium carbonate and a testing the gas evolve with a burning matchstick. Let's see the activity of this burning effect. For that, we require take one calcium carbonate or a limestone in a boiling test tube. Then after, place a delivery tube with a cork on the tube. Heat the test tube with the burner. Put a matchstick near the opening of the delivery tube. By this process, you can observe that a gas evolves from the test tube and passes all along the delivery tube. The gas put of the burning matchstick at the open end of a delivery tube. You can see the white precipitation is formed at bottom of the test tube. Now let's see the learning outcomes, or you can say the conclusion. In this reaction, the compound calcium carbonate, or you can say the limestone, breaks as a reactant when the heat is applied. This is why the reaction is called the thermal decomposition and endothermic decomposition process. Here the quicklime is first product with the precipitate at the bottom of the boiling tube, and the gas which is evolved, that is a carbon dioxide. Now let's see the another activity, the heating of lead nitrate and the emission of a nitrogen dioxide. Let's see the activity. First of all, take a 0.5 gram of lead nitrate, means the PbNO3 twice. Then close this test tube with the cork and use the clamp and the stand arrangement to hold the boiling test tube as seen in the figure. Now heat the boiling test tube and see the observation. The gas is evolved from the boiling tube. The color of the gas is become a brown The white precipitation you can observe at the bottom of the boiling test tube, which is a lead nitrate. Now let's see the result. In this reaction, the compound lead nitrate decomposed or break as a reactant when we heated it. This is why the reaction is called the thermal decomposition, and it is also the endothermic in nature because the heat is absorbed. Lead oxide is first product which is precipitated at the bottom of the boiling tube, and whatever the brown color gas is coming out from the boiling test tube, that is a nitrogen dioxide, it is passed through a pipe delivery tube and gets collect in the gas collecting jar. Now let's see the next activity, which is heating of lead nitrate, which is electrolysis of water. Let's see the activity. In the electrolysis of the water, first of all, take a plastic mug as shown in the figure, the rubber stopper, test tube, 6-volt battery and test tube stand. Drill 2 holes at the base of the mug. Then after, insert a 2 carbon electrode into this hole using a 2 rubber stopper, by which we can hold this carbon electrode. Now connect this electrode to a 6-volt battery. Now add the electrodes in a water by filling the mug with a liquid. Add a few drops of a dilute sulfuric acid to a water for a conductivity. Because the pure water is a not good conductor of heat, that's why we have to add some drop of the acid. Now invert 2 water-filled test tube over the carbon electron as shown in the figure. Now switch on the circuit and see the observation. During the observation, we can observe that the gas bubbles that is appear in both the test tube. There is a rise in the level of the water in both the test tube to a different extent. Now let's see. Carefully remove this test tube completely filled with the gas. Now bring a burning candle near the mouth of both the test tube and see the observation. You can see in the observation that the candles continue to burn in the presence of the gas coming from the first tube, which is taken as an anode, and the second tube, that is taken as a cathode, that candle puts off due to the presence of hydrogen. In this reaction, the compound water decomposed or break as a reactant under passing electricity. This reaction is required the energy in the form of electricity. That's why we consider this as an endothermic reaction. The hydrogen is the first product which is put off the candle flame, whereas in the second flame, the second product, that is of oxygen, which is allowed to candle more burn. Now let's see the another activity, that is a silver bromide, which is light yellow in color. Let's have a look. First of all, take the silver bromide, keep it into the sunlight, observe its color. Let's see the observation. Here, due to the sunlight, the decomposition processes occur. Due to the decomposition, the color of the silver bromides become a change. Now let's see the result. In the result you can see, due to the presence of the sunlight, the silver bromides is baked down and converted into the silver and bromine. In this reaction, it's required the energy as a form of sunlight. That's why this process is we consider as an endothermic, or you can say the photochemical reaction. The silver is the first product which is a grey in color, whereas a bromine is the second product which is liberate in the form of gas. Let's see the another activity. This activity is based on the displacement reaction. Let's start the activity. In this activity, first of all, we have to take a conical flask, tie it with the balloon at its mouth, as seen in the diagram. Take a small quantity of a zinc dust into the flask. Slowly add a dilute HCl, means the dilute hydrochloric acid, into the flask. Put a cork on the flask and close it well. Now let's see the observation. You can observe that the gas bubbles is appear from the solution. The balloon bursts out. Now let's see the result. Here the element zinc in a solid state, which is react with the compound a dilute HCl, means the dilute hydrochloric acid, in an aqueous state and gives a aqueous zinc chloride and hydrogen gas is elaborate. The element zinc being a more active element because it displaces the hydrogen from its place in a hydrogen chloride reactant and form a product of zinc chloride. Hence, this reaction is known as a displacement reaction. Let's see the another activity. The iron nail and the copper sulfate solution, compare before and the after experiment. It is also a kinds of displacement reaction. Let's start the activity. For that we require sandpaper, iron nails, copper sulfate solution, stand, test tubes and test tube stand. Let's start the activity. Clean the 2 iron nail with the proper sandpaper. After that, take a 1 test tube, label as A, take another test tube, label as B. After that, take 10 ml of copper sulfate solution in both the test tube. Now, take 1 nail with tie it with the thread properly. Then after, keep into the test tube A as shown in the figure. Allow it as approximately 20 minutes. The other nails and the test tube B are for the reference. Take the nail out from the test tube A. Compare both the solution as well as a nail. Now let's see the observation. The nail taken from the test tube A, which turns into the brownish color, whereas the color of the copper sulfate solution has faded from being blue. So what is the conclusion? Here the element iron, it is in solid state, which is react with the compound copper sulfate aqueous state and give a aqueous iron sulfate and a solid copper. The element iron being a more active, that's why it's displays the copper from its place in a copper sulfate and reactant and form a product called the iron sulfate. Now let's see the another activity, the formation of lead iodide and the potassium nitrate. Let's see the activity. In this activity we require lead nitrate, potassium iodide, test tube and distilled water. And test tube stand. Take a lead nitrate and add it into the test tube filled with 5 ml distilled water. Take a potassium iodide and add it into the another test tube with the equal amount of distilled water. Now mix both the solution in the test tube well and note it down your observation. Now let's see the observation. In the observation you can see the change of color is occur. A yellow color insoluble precipitate is formed into the test tube. Let's see the conclusion. Due to the process between the lead nitrate and the potassium iodides, it's become a lead iodide and the potassium nitrate. After the process, we can see the precipitate of the lead iodide, which is yellow color. Now the lead ion of reactant lead nitrate combine with the iodine ion and the react with potassium iodide to form the product lead iodide as a precipitate. The other product form is a potassium nitrate, which is in aqueous state and remain as a reactant. And this is also a example of the precipitation reaction. Now let's see the another activity, that is of oxidation activity. In this activity we see the oxidation of copper to copper oxide. For this reaction we require brown color copper powder. First of all, take 1 gram of copper powder in a brown color in a china dish. Place the dish on the tripod stand with wire gauge. Heat the copper powder using a Bunsen burner. Now let's see the observation. The color of a copper powder is turns from brown to black color. Now let's see the outcomes. Here the solid copper powder burns into the presence of the oxygen which is present in the air and converted into the copper oxide, which is black in color. The reactant copper gains oxygen in the reaction, hence this process is known as a oxidation reaction. Now let's see the reduction activity. Take the black copper oxide in a glass tube supported by the two stand on its both the end. Now put the cork with the nozzle in them to the end. Pass the hydrogen gas from the nozzle of the first cork and allow the gas to leave from the nozzle's another end. Use the Bunsen burner to heat the black copper oxide powder in the presence of hydrogen gas. So the reaction is copper oxide with hydrogen, then it is splitted down into the copper and water. Now let's see the observation. After this reaction, the black color of the copper oxide powder is changed to the brown color. Now reduction learning that the copper oxide gains the hydrogen, or you can say the loss of the oxygen, and turns it into the copper again. Here the hydrogen is added and the oxygen is released. That's why this process is considered as a reduction reaction. Together, the oxidation and the reduction is both the process considered as a redox reaction.